no daily quiz. Didn't get quite far enough, not enough practice to do anything more than just the basics. Day one is usually front loading, the basics of the functions, but then we also had our trig basics quiz. So for anyone who was gone, you just got to make that up at some time. Preferably, okay. I would hope that anyone who is missing anything will do so as soon as possible. I strongly recommend you make a point of getting it done Monday during Spartan time. Otherwise, scheduling with me before or after school today or Monday, because anyone who pays attention to the weather right now, Tuesday, Wednesday next week, spearfish current forecast is at 19 total inches. So in the 2 days, it's supposed to be, it's going to be a good one. Okay. It's going to be a good one. Right now, Deadwood is forecast for, I think, 27. Now, this is going to change because the track is changing. Y'all know how the spearfish is right on the edge of the northern hills. So it all depends on whether the air mass bumps up against the hills and skirts around, or whether it gets popped up in elevation and then it dumps. So they don't know for sure what's going to happen. They just know it's going to be good. Okay, the odds are that we will have a snow day. If that's the case, I'm torn between watch an old video or do nothing. I would rather do nothing. But we also have those junior state assessments coming up. I think folks would rather do a video and watch the thing on a day when you have nothing going on, as opposed to I have to make up 2 other classes because they're also mixed classes. We'll see what happens. Okay? So I'm just letting you know that's kind of stuff that's going on. If you're missing any tests, try to get them done Monday at the latest, because next Thursday is the midterm as well. So we left off with, we were just starting to mess around with the period of these things. Do you remember what the deal was behind it? How does it change the graph? How do I find the period? Okay, so like we did 3A, so we're going to be doing 3B and C right now. Do you remember how to find that period? 2 pi over B gets me the period, so that's from where I start to the end of the cycle, where it starts over. And how do I find the marks in between? Divide it by 4, because they're always at 1/4 of the period. Okay, so we did the top example, we did 3A. Do you think you're okay to give it a whirl on your own? Or see one more to be safe? See one more? Okay, which one do you want me to do, sine or cosine? Cosine? Okay. Or wait, we did 3C. So you have one to base that off of. I'll do 3B because A and C are very similar. So we start with, identify that the period of this guy is 2 pi over B. B is currently 1, so just 2 pi. The quarters of that one are going to be, take this times 1/4, pi over 2 increments. The period of this one, 2 pi over B. B is 3. So if that's the period, take that times 1/4, and my quarters are going to be at 4, 2, cancel 2, and pi over 6. So, who's bigger? The regular sign of x, right? Pi over 2 is bigger than pi over 6. 2 pi is bigger than 2 pi over 3. So, That's how far I'm going to go out so I can fit everything. I'll go from 0 out to 2 pi and negative 2 pi. My quarter marks are by pi over 2, pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. What about my vertical axis? What amplitude on both of these is 1. So I'll just put 1, 0, negative 1 there. So I'll start by graphing the first one. Sine starts at my midline. Sine of 0 is 0. And then sine of pi over 2 is 1. So it gets that up, middle, down, middle pattern. Down, middle, up, middle. I connect the dots. Okay. Now, how am I going to adjust this so that I fit this guy in? How many of pi over 6's fit into pi over 2's? 3 of them, right? So I'm going to have to take each of these areas and cut them into thirds. And I think this is where some of us start getting a little cross-eyed, because you already have a graph there. If you already have a graph there and you already have those lines where you made all of your points, you have to really slow down and remember that I'm going on these tick marks now for the other graph. Okay, this one, sine of 0 is still 0, but when I do my up, middle, down, middle thing, it's on these tick marks. So I go over pi over 6 and it's up. I go over pi over 6 and it's middle. I go over pi over 6 and it's down. I go over pi over 6 and it's middle. Over pi over 6 and it's up. Middle, down, middle, up, middle, down, middle. And you see that at 2 pi, when 2 pi over 3 and 2 pi would actually line up by as a common multiple, that's when they mash back together. That's when the cycles reconnect. So over pi over 6, down. Over pi over 6, middle. Over pi over 6, up. Middle, down, middle, up, middle, down, middle, up, middle. Connect your dots, try to keep it curvy. And you can see 3 of these cycles in 1 of those cycles. Okay? So you start by finding the period and the quarter marks for both. Determine which one's bigger, go out that far. Make that graph. That graph is going to be your normal, no, not you, your normal graph. Okay? Then, if I'm trying to fit them on the same axes, your next step is to break those increments up to match whatever the crap is going on with the other one. And this will be the last time that I say do them on the same axis. Because after this, I'm going to say, screw it, do them on different ones, because it gets kind of messy. Okay? So one more, 3C. Just see if we can wrap our heads around it. And then we'll start messing with them. Hey, talk back to me. Find the period. Get your quarter marks. Oh, dear God. Okay, my wife's kind of a weather aficionado. She just follows the weather apps religiously. She follows all the different meteorologists in the area. She said spearfish's total is up to 25 now. So we're gonna have a good one next week.
Well, no, world record was Atlas.
Come on, do the problem, do the problem. That was my fault. Be quiet, do your problem. I didn't have to whisper. This ain't a library. So the disparity between first and second hour is just remarkable.
Even our class last semester. Yeah.
Yeah, your class last semester was actually pretty lively. I think I had to smuck the front table with the pool noodle a few times. Dawson's a character. I like him. Well, so far, everything we've done, the other three examples, it was 2 or 3 of these cycles in that space, and it's starting to get a little cramped. This one, you're really going to start to hammer home why we don't do that with other graphs. Or, I mean, you can, but it gets really messy. The larger period is 8 pi. With quarter marks of 2 pi. Yeah. Pi, 4 pi, 6 pi, 8 pi, negative 2 pi, negative 4 pi. No kitty, my pot pi. 1, 0, negative 1. Okay. I'm going to reverse my order on this. I'm actually going to do the compressed one first, because otherwise I'm not going to be able to see what I'm doing. Because 4 of these fit in one of those. So that means the entirety of this graph is going to be right there. You see why I'm going to start with the little ones so I can actually see what's going on. So I'm going to take all of these quarter marks for Big Kahuna, and I'm going to cut those into quarters to fit Little Kahuna. And put 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3. So here we go. This guy. The cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. 3 pi over 2 is 0, and of 2 pi is 1. So we're going to middle, down, middle, up, middle, down, middle, up, middle, down, middle, up, middle, down, middle, up, middle, down, middle, up. And then, this one should make Finn happy, who's been drawing all over my board in his papers. Try to actually hit the points. Ah, kind of missed that one. Okay. Versus the other one, a lot cleaner. That one starts at 1, middle, down, middle, up. Middle, down, middle, up. And you see 1/4, not 1/4 stretch, 4 times stretch. 4 times as big as the other ones. Okay? Now, the reason that we're going to stop doing them on the same set of axes is what happens when I've got this one and this one, except this one has a -5 pi over 12 phase shift, and this one has a 2 pi over 3 phase shift. None of their points overlap, and it's a mess. Okay? So, moving forward, we're not going to be having them on the same axes. We're just going to do one at a time. Now, the period, we're going to get practice with that. Because all of the ones moving forward, it's going to be period and phase shift. It's going to be period and phase shift and vertical shift. So every time we're just adding a step. First, an example of this, just moving with the equation. Remember, y equals, are we dealing with sine or cosine? Temper scale, and sine function. So a sine of bx plus c plus d is my general form of this. Musical notes classified by frequency. Middle C has a frequency of 620 hertz. A frequency of. Go back to that page that had period and frequency on them. What was the difference from period to frequency? Close. Oh, 1 over period, yes. So it'll be, instead of 2 pi over b, b over 2 pi. They just told me 262 is b over 2 pi. So that means b is 524 pi. Use this information at the information at the information at the left is just a picture of a scale. It doesn't actually do anything to this. To model the initial behavior of a sound wave, middle C with a amplitude of 0.2. So the frequency I can use to find B. What does amplitude get me again? A. That's it. Y is A sine of BX. Done. They're just making sure that you know where the different parts of the equation come from. Okay? So, same thing down here. Write a new equation. See if you can put the right thing in the right spot. They give you frequency and amplitude. How do those get you A and B? Write the equation. Fairly quick, right? Just like the previous one, if I have a frequency of 524, then that's B over 2 pi. Multiply, B is 1048 pi. Amplitude is 0.1. Y is 0.1 sine, not 0 point sine, of 1024 pi x. What? I mean, I wrote it over there. All right. Does anyone else see it? Anyone else see why the board is extremely distracting to me and adding to my headache? It's blinking.
Actually, I don't think I want to see.
Because then it distracts you for the rest of the class, right? So I have to restart the whole works, but we'll just try to grunt through. Already talked about these general forms. I had said B, we use 2 pi over B to find the period. Do you remember what we said about C? Well, it's right there, right? It is the horizontal translation, but again, sinusoidal functions are special. So they get special names, and they call it, instead of a horizontal translation, they're going to call it a phase shift. Notice that every time we've done a f of bx minus h, when we had our general form of transformations, we always separated b from the x minus h, and we had x minus h, so we knew what the horizontal translation was by our whole bass-ackwards thing. Well, these guys, instead of leaving it like that, they're just going to say bx plus c, and you notice if I solve for x, that's my phase shift. Just like over here, if I were to solve for x, that would give me my horizontal translation with my horizontal stretch or compression. So it's the same thing we've been dealing with. They're just going to tweak the form a little bit to fit what these functions do. Vertical shift. It's still going to have an amplitude that tells you how far off of the middle it goes, how far up or down it goes, but now I'm going to move the whole honking thing up or down. So we call that the midline. D is the midline. So there's two schools of thought. The book really wants us to just draw the midline up here, and then do my graph there with the axes over here. The way that we usually do it is we just relabel and then put the pi over 2, pi, 3 pi over 2, 2 pi, because now it looks quote unquote normal. See how I'll just change my vertical axes? Okay, just like with the amplitude, I just changed my vertical axis instead of actually stretching it out 5. So, the idea that I can just make the same graph every single time, I'm changing the labels on the axis to make it accurate. So, here we go. State, amplitude, period, frequency, phase shift of the thing, and graph 2 periods of the function. So off to the side, I'm going to start writing stuff. First up, amplitude. Look in the A spot. There's nothing there. So the amplitude is still 1. Period is 2 pi over B. What's in the B spot? It doesn't ask for it, but right next to that, I'm going to write my quarter marks. Take 2 pi over 3 times 1/4. We just did this. Pi over 6. Okay? But now it's also going to ask for phase shift. Phase shift is negative C. Be careful, what's C? It's always bx plus c. So it's a negative pi over 2 over b. So my phase shift, negative, negative, positive, pi over 2 over 3. Pi over 2 over 3 is what? Pi over 6, right? Flip the second multiply. Dividing by 3 is multiplying by 1/3. So positive pi over 6. And I'm just going to start writing it now. There wasn't a vertical shift. So this is baby steps where they've given us a a phase shift that matches my quarter marks. So I'm going to do this 2 ways, and you decide which way you prefer. Way number 1. Okay, don't go writing stuff. Don't go writing stuff in pen, for sure, until you see both methods and you decide which one you like. Way number 1 says, I will still keep this my y-axis. I will still go out to 2 pi over 3 and negative 2 pi over 3. I will go by my quarter increments of pi over 6. 1 pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3, so I know I'm doing it right. Negative pi over 6. Negative pi over 3, negative pi over 2, and so on. My amplitude is 1, so I'll put 1 and negative 1 and all that. But then, when I go to make my dots, I have to shift to pi over 6 when I start. Normally we say sine of 0 is 0. Well, now it's going to be sine of 3 times pi over 6 minus pi over 2 is sine of 0. I have to start here. And then up, middle, down, middle. Down, middle, up, middle, down. Okay. That's option 1. Most kids don't like that because these numbers won't always line up with the y-axis. Option number 2 says if I get to label stuff the way that I want, how about I just label it by starting at whatever the phase shift is? I'll just put pi over 6 where I start. If I have to shift over here and that's where I start my graph, why not just start my graph there? And then count by pi over 6. So pi over 3, pi over 2, 2 pi over 3, so that's 4 pi over 6, 5 pi over 6. Back, pi over 6 is now 0, negative pi over 6, negative 2 pi over 6, or pi over 3, negative 3 pi over 6, or negative pi over 2. Still have 1 and negative 1. You see where this is my actual y-axis? But I'm just going to label my axes wherever I feel like. Because then I get to make my normal sine graph, where I start at 0, the midline, and then up, middle, down, middle. The normal sine graph versus middle, down, or down, middle, up, middle. See, that's what my normal sine graph looks like. But if I just shift my axis instead of shifting my graph, I get to make the same graph every time. Some of you did this when we were reviewing our quadratics. Remember that quadratics move in successive odds? Over 1 up 1, over 1 up 3, over 1 up 5. And what happens when it's like 3/4 x squared plus blah, 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 blah. It was kind of a pain to graph, right? But if you knew where your vertex was, I could just make the same graph every time, and then on my y-axis, I would say by 3/4. I would just cheat. I'd label the axis so it worked for me. That's what we're going to do with these. We'll label our axis so it works for us. Now, the first time we see phase shift, we're usually a little bit not too happy with it. So I'll do one more. We'll do this guy. Start by stating my amplitude. 3. The period is always 2 pi over b. b is currently 2, so pi. Which means my quarter marks, take 1/4 times that, pi over 4. Follow so far. Okay, that's all the stuff we were doing. Now I'm also going to include my phase shift. Negative c over b. Well, c is a negative pi over 3. b is a 2. Negative negative is positive. Pi over 3 times 1/2 is pi over 6. This is what I mean by these are going to start getting ugly. Because I have a phase shift of pi over 6, and then I'm moving away from that in pi over 4 increments. And we know how much kids love fractions. What is pi over 4 plus pi over 6? Ew, common denominators. What are you bringing back 7th grade for? You're going to have to do common denominators. What's the least common multiple between 4 and 6? 12. So I'll label my phase shift. I'll start my graph at pi over 6, which I know is 2 pi over 12. My quarter marks, times 3, are 3 pi over 12. So right now I'm at 2 pi over 12. I'm going to move over 3 pi over 12. 3 pi over 12, 3 pi over 12, 3 pi over 12, and reduce them along the way. So, that's why kids hate this chapter, because graphing plus fractions. This is 2 pi over 12 plus 3 pi over 12 is 5 pi over 12? Oh God, if we're struggling right now, come on now, stay with me, please. Okay, add another 3 pi over 12. 8 pi over 12, reduce it. 2 pi over 3. 8 pi over 12 plus another 3 pi over 12. 11 pi over 12. 11 pi over 12 plus another 3 pi over 12 is 14 pi over 12 and reduced. All right, go back the other way. 2 pi over 12 minus 3 pi over 12. Negative 1 pi over 12. Negative 1 pi over 12 minus 3 pi over 12. It's negative 4 pi over 12 reduced negative pi over 3. Negative 4 pi over 12 back another 3 pi over 12. Negative 7 pi over 12. Negative 7 pi over 12 back another 3 pi over 12. Negative 10 pi over 12 reduces to negative 5 pi over 6. Now I want you to think about this. Where is the y-axis right now? Where is 0? It's 1/3 of the way in between those two. This is why kids hate chapter 4. Fractions and graphing. How dare you? Okay. So, but think about this. Now that I have this labeled, now that I have my midline of 0 and my amplitude of 3, now that I have labeled the axes in such a way that it works for me, I get to make the same graph that I've been making. Does sine start at the midline or the maximum? So, middle, up, middle, down, middle, down, middle, up, middle. So the graph itself is just the same stuff we've been doing. It's labeling the axes that sucks. Now I'm going to show you a trick. Usually I make kids do this because they're freaking fractions. You should know how to do fractions. But some of us really dislike fractions. So I show you a nice little trick with our graphing calculators. Remember how if we didn't know all of our squares and cubes and fourths, we were able to put those in? I've got a trick with these. I would like you all to go to Stat, Edit. Oh, suppose I should clear all that out, huh? Second plus 7, enter, there. All right, Stat, Edit. Now, whenever we do this, we have our phase shift in the middle, right? And then we go 4 spaces out of our quarter marks. So, if I say, how do I want to write this? So phase shift plus 1/4, so 5. That's going to be minus 1/4. Oh no, we're going to do this in y equals. Okay. Right? Yeah, we are. Okay. What was our phase shift again? Pi over 6. So we're just going to write 1/6. Make sure you write it as a fraction, because it will then auto-populate your table as a fraction. What? All right. Well, it's not my room. I don't have to do paperwork. Come on. So 1/6 pi was my phase shift. Didn't we keep going to either side of it by increments of how much? Pi over 4. So I'm going to take alpha y1. I'm going to take my y1 plus 1/4 x. And say, huh? Why are we doing this? Because now, when I go to my table and it is auto-populated, look at what the values were. The phase shift, first quarter mark, second quarter mark, third quarter mark, fourth quarter mark. Okay? I suppose I didn't need to put y1 plus. I could have just said 1/6 plus 1/4 x. Okay? So your quarter marks, your graph, can be found by saying y1 is phase shift plus quarter mark x, and then going to your auto-populated table. If you don't want a fraction, because you know likey the fraction, you can do this to get all of those fractional values without having to think too much. I'm going to ask that you try to do them for real and then use this to check your work. Because again, if you don't understand how to find them, you just memorize the calculator shortcut, you're going to get screwed over pretty hard when you have, oh, I don't know, a multiple choice question about where are the maximums of this particular sinusoidal function on your final. Because you won't know how to find them yourself. Okay? But that's a good way to check your fractions on your x-axis. Now, sometimes the fractions will line up nicely. Sometimes they're disgusting. It all depends on the equation. The reason that I did 5b is because I know that 5a actually comes out pretty nice. Like, it's not terrible. So if you would please, find amplitude, period, quarter marks, phase shift. Where do I start my graph? My quarter marks tell me in what increments I move out from there. Make sure you have all of that information. Check with your neighbor to make sure you got the same information. Then start making your graph. Make sure you have the right information first. Then let's see if we get our graph right. Okay. So this one's got nice fractions. I have a phase shift of negative pi over 2. And if my quarter marks are pi increments apart, that should be fairly easy. 1 pi over 2 plus 2 pi over 2. 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 Okay, those should not be bad. Another aspect of this that bothers some kids is that the left and right portions of the graph are not symmetrical. Like, I can't just take the positive side of the graph, throw negative signs on it, and now it's the left side of the graph. Like, I can't do that because the phase shift means it's reflected about a non-zero point. Amplitude is still 1. 1, 0, negative 1. And once the axes are labeled, you make the same graph. I'm going to go make a cosine graph. The numbers that are there don't even matter. I start at the maximum and then middle down, middle up. Middle down, middle up. It's the same old cosine graph that we've been making. I just had to change my axes so that it would fit. I hope you prefer that method because it's so much easier. Because the alternative, where's the y-axis right now? The y-axis is right here, halfway in between negative pi over 2 and pi over 2. Which means all of my quarter marks, all of my special values would be halfway in between the boxes if I tried to fit this to a normal set of axes. If that was the case, if I tried to fit this to someone else's graph of 0, 2 pi, pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, 1, negative 1, 0. If I was trying to fit this to someone else's, a phase shift of negative pi over 2 means my cosine value starts here, maximum. But then if my quarter marks are in pi increments, then I would be all the way until here. 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 I wouldn't actually see my full 2 periods. Now imagine what happens when that starts getting stuff like 5 pi over 7 phase shift with a 2 pi over 3 quarter mark. Hi. Phase shift, negative pi over 2.
Not phase shift, the quarter mark there, a bit wonky.
I went pi, pi, pi. Oh yeah, I did. Oops. So it's even worse than that. Okay? Because doing it that way is Just garbage. Instead, label the axes your way, and then just make the same graph every time. Okay? So we need to practice that before throwing anything else with it. Vertical translations of 5. Those are vertical translations of. Do you know what? No. We'll keep going with theirs, and then I'll throw the ugly stuff at you afterwards. Okay, we'll keep getting more practice with not bad ones before I throw the what the hell is this at you. Okay? So this is going to be the same thing. I'm just going to shift it up or down. Now I've got a vertical shift with it. All that means is I'm going to relabel my vertical axis as well. Say all the stuff you know. There's an amplitude of 1. There's a period of 2 pi over b. B is currently 1. There's quarter marks. They never ask for it, of 1/4 times 2 pi is pi over 2. There's a phase shift of negative c over b. And now we're going to have a vertical shift of negative 1. All the vertical shift does, no joke, the only thing that it does, what they want us to do is put my midline here, and they want me to make my graph around that. I don't want to do that. What if instead I just labeled negative 1, amplitude is 1, so 0, negative 2. Right? Instead of moving the whole graph down, how about I move the axes instead? Okay. Now, see if you can puzzle this out before I start making the graph. What happens when the phase shift is the period? It takes 2 pi to complete a cycle. I'm going to shift back 2 pi. There is no difference. The phase shift is the period. That's saying, all right, this happens every week, but we're going to start next week. It's still going to happen every day on that week, or every week on that day. There we go. Like, there's no difference. If I were to start at negative 2 pi and go by pi over 2 increments, well, now that's negative 3 pi over 2, negative pi over 2, and 0. Right? That's just the left half of our normal graph. So you have a choice, and both are correct. It just says make 2 periods of it. I could do this, going back to negative 5 pi over 2, negative 3 pi, negative 7 pi over 2, negative 4 pi. I could make my graph right here. Or, understanding that that's what it's doing, I could just make my regular graph. Because the phase shift was also the period. You have that choice available to you now. I don't care which you do. Which do you prefer? Which one seems to make more sense? Keep putting the phase shift in the middle, or, oh, hey, I see a thing, so I'm going to do something else? Negative 2 pi in the middle, or 0 in the middle? Okay. If I know it's going to do that, I might as well. Pi over 2, pi, 3 pi over 2, and 2 pi. And then here we go. A sine graph starts at, suppose technically I can start my graph back here, right? Starts on the midline. Up, middle, down, middle, up, middle, down, middle. Which is the exact same as if I had started in the middle at 0. Okay. I swear if that's another baby announcement, I'm going to be just laughing. Work. She had her first kid right around when we had our second, and she was sleeping and we weren't. She thought it was kind of amusing and then was afraid to talk around me because I was going on 3 hours of sleep every night for 7 months straight. And I just kind of laughed at her and I said, have another one, I dare you. And that's the second one is kind of doing to her. But that's the general idea behind it, is what the book wants us to do as opposed to what we are going to do. The book wants us to do this, right? -2, -1, 0, 1, 2. And then they just want us to put a dotted line down the middle and say that's my midline. I'm telling you, it's easier to just relabel the axes. Okay? So if you're just relabeling that vertical axis, this is just more practice with stuff. I want us to start with 6B because I'm actually going to modify 6A. Y'all, you need to get used to this idea. Saw several of those expressions. When it has a fraction with 1 on the numerator, that's actually good. That means it gets bigger and has nice fractions and whole numbers. Okay? Because it's always divide by the reciprocal. You want these ones. Because I'm going to modify A so we get some practice with a little oomph to it. It looks messed up. It's not. It's actually really easy. Okay, write out all your information first. Check with the neighbor, make sure that is correct before starting to put pen to paper for that graph. Seeing fractions and panicking. Okay, it's actually the other way around. If I see fractions inside those parentheses, I'm probably okay. If I see integers in there, here we go. Okay, do we got the right information? Once you have the right information, can you make the graph? Is that her TV again, or was that someone's stomach? Dang, dude. Feed me, Seymour. There's like two people in the room who are going to understand it. Little Shop of Horrors. It's a movie from like the 80s. Rick Moranis. He's got this big Venus flytrap that grows up to the size of this room. And it's like he has to go murder people and feed them to the plant. And feed me, Seymour. No. God damn it. I feel older every day. All right. Phase shift is 2 pi. Quarter marks are 2 pi. So 0, negative 2 pi, negative 4 pi, negative 6 pi. So I could have started with 0 actually on that vertical axis, right? If you want. And then 4 pi, 6 pi, 8 pi, 10 pi, no kitty, my pi. And my midline is my vertical shift, negative 3. The amplitude is 1/2, so I'll call this negative 2.5 or negative 5/2, negative 3.5 or negative 7/2. If I just label the axis like that, then I don't have to move anything. If I label my entire graph like this, I don't have to move anything. I can just make a normal sine graph. Sine starts at midline, up, middle, down, middle, down, middle, up, middle. Connect the dots, try to keep it curvy. I hear at least one transistor radio in the room. Now, I could have done it like this by starting my vertical axis at my phase shift. Because I understand that I would line up with that 0, what I could have also done is just leave 0 here. Put my negative 5/2 here, my negative 7/2 here, my negative 3 there. I could have done it that way, and I would just know that I have to start at my phase shift. Okay, so if your phase shift lines up with either the period or the quarter marks, you have the option of making a clean graph that goes back to 0. But if they don't, I would not recommend trying to do that because it's going to look gross. Okay, so you did it where things come out nice. This is the exact same process. Exact same process. We're just going to have some fractions in there. Instead of cosine of x plus 1, it's prime time. That's the era I grew up in. Michael Irvin, Deion Sanders, Troy Aikman, Emmett Smith. Mid-90s Cowboys, the average weight of their offensive line was 340 pounds. Well, I grew up in that era. A lot of lunch table arguments in elementary school. Okay, make sure you got your information correct first. Check with your neighbors before you start trying to graph it. If you need to use your calculator to do the fractions for you, might not be a bad idea. Oh, I went with all integers. The next one we do is going to have prime fractions. This ain't ugly. This is cute in the right light. Oh, did I forget my pi? Yeah, let's put the pi in there because otherwise I mean, it is still in radians. You're just not going to have pies. Sorry. I mean, I'm betting some of you just naturally wrote it there anyway, but. Okay, make sure you got the information right. I'm doing this in stages. I did all integers. Still end up with fraction stuff all over the place. But because I did all integers, that means my phase shift and my quarter marks are not terrible. Power 6 is 5 power 2. your axes. Check my math. Papa Bear's going to try and do fractions by mental math in the morning. This is bad news. If you're going to get brownie points, it's probably going to be here when I try to do basic arithmetic. Nah, not really. We good on our axes? And then, if you label it that way, you just make a cosine graph. Cosine always starts at my maximum. Middle down, middle up. Middle down, middle up. Okay? All right. Then, one more, and here comes the mathematical gauntlet. I'll tell you right up, do not try to fit this to these axes. It will not go well. Just make your own. Let's modify this filler. Get him! Get him! Not true. In the inaccurate words of the youth, cringe, bro. Yep. There was a brief discussion on generational slang in the Game Club Discord last night, where someone said they wanted to try to get their parents or teachers to, was it from Jeopardy? Yeah, it was a Jeopardy question because sus was one of the answers. Yeah. Yeah. Said they want to have a Jeopardy question where middle-aged people have to say, I forget what it was. So I responded, "Nah, we Gucci." You know it's not cool anymore when someone over the age of 35 is saying it. Okay, it ain't gonna be pretty. You might have to go fraction town to get your axis correct. times 1/4, so half 5 pi over 14. Okay, this actually ended up fine because they share a denominator.
Yeah.
That's not bad.
I'm just not gonna.
Okay. Plus 4.2. So 1.021. Negative 7.379. Negative 45 pi over 14. Negative 40 pi over 14 is negative 20 pi over 7. Negative 35 pi over 14. And my 7, 7 is 5 and 2. Negative 30 pi over 14. Is negative 25 pi over 14. Negative 50 pi over 14. My 2 is 25 and 7. Negative 55 pi over 14. Negative 60 pi over 14 is 30 and 7. Negative 65 pi over 14, nothing. Check my mental math. I hope you just ain't copying mine down because I don't know if I did it right. I'm a burned out husk of a mathematician. Okay. And then sign. Middle up, middle down, middle up, middle down. Whoa. Bad Sullivan. Mm-hmm. Mm-hmm. Your midline is always a vertical shift. Your amplitude is how far off of that vertical shift you go. So you just add or subtract it. So the negative 3.179 plus or minus 4.2. Okay. Now there's a whole other thing with doing these from a table. We don't got time to even start it. What if these were even nastier numbers? This happened with, because I chose all relatively prime numbers, meaning nothing could cancel or reduce, my quarter marks ended up having the same denominator as my phase shift. If there is reduction between them, you might end up with a quarter mark of 5 pi over 14, but a phase shift of negative 27 pi over 3. Then your fractions get real dumb real fast. I would just use the calculator to do every bit of that. Are you all cool with? I saw a couple of you doing the calculator trick to do this. But you can get those, you can get that x-axis, that horizontal axis. Okay? All right, we'll just cut it off there because we ain't ready to go on to the next part. We just don't have enough time to even start it. That'll be where we pick up on Monday. Like I said, next week, yeah, next week, just they don't know what's going to happen.
So when would our testing normally be?
You had your test was Tuesday this week, right? So Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday is when it should be. Now, what's really going to be messed up is if we're supposed to have our quiz on Wednesday and we have a snow day, it just gets moved to Thursday, no big deal. But if we have two, that's when we might have to do a video lesson just so we can get our quiz in on that Thursday so you don't have a 4-day weekend in between I learned it and here's your quiz. Okay? So next week is really a crapshoot. I'm not sure what's happening. We'll see.